All right, so we're going to start our unit on rational exponents. Before we get into that, we need to remind ourselves of what we're supposed to do with our exponents when we're multiplying, dividing, like bases, that kind of thing. And this is all Algebra 1 stuff. Some of you guys, it's been a little while since you've seen it. So we wanted to review some of these exponent rules before we get into our rational exponents. We're going to use this particular unit, this particular homework, to talk about just how to simplify expressions using the different rules for exponents. And just as a quick reminder, again, I won't go through the whole reasons as to why or verify the rules or whatever. We did that in Algebra 1. But this should help you remember that if you're multiplying like bases, then what you're going to do is you're going to add the exponents, right? Here, m and n, we'd add those together. That's if you're multiplying like bases, right? Two separate bases that are the same, we're going to add those exponents. If you only have one base, like in the power rule here, you're raising an exponent to a power, an exponent to an exponent. Then you're going to multiply them. It's kind of like distributing. It's kind of what you want to do when you have a number outside the parentheses anyway, is you want to distribute it. So we're going to take this exponent n and distribute it to any other exponent we see inside the parentheses. So we're going to multiply m times n. And then your division rule, if you're going to divide, if you divide two like bases, again, they have to be like bases, then instead of adding, we're going to subtract the two exponents, right? I'm confident this will come back pretty quick as we work through this. All right, so some examples for you. Here, we've got an exponent sitting outside of parentheses. It's pretty natural for us to want to distribute any number that's sitting outside of parentheses. So we're going to distribute that exponent of 3 to all the exponents inside the parentheses. Yep, so that means we're going to multiply the 3 times the 2 there. But don't forget that the y has an exponent also. It has an exponent of 1. So we're going to distribute that 3 to the 1 there. And the negative 3 has an exponent. It's a 1 as well. So we're going to distribute that out to the 1 exponent on the negative 3. So we get negative 3 to the third power, x to the sixth, y to the third. And then to simplify this, we do want to go ahead and multiply this out. So negative 3 to the third is negative 27, x to the sixth, y to the third. And then we're done, right? There's nothing else we can do. All right, 2, kind of more of the same. There is one more rule that we didn't have up at the top there that we're going to add once we do this. But again, we have this 2 sitting on the side of the parentheses. We want to distribute that 2 exponent, that squared exponent, to the y exponent, the x exponent, and yes, indeed, the 5 exponent, which is a 1. So we'll get 5 squared, x to the negative 4th, y to the 10th, right? 5 squared is 25, x to the negative 4th, y to the 10th. But what we didn't talk about in those other rules is that you cannot have a negative exponent, right? When you have a negative exponent, and you can try this out, if you type in 2 to the negative first power in your calculator, and we can talk about how to do that next. There's a y to the x button that you would use in your calculator. But anyway, if you type 2 to the negative 1 in your calculator, it's going to spit out either 1/2 or 0.5, which is 1/2. And that's because it's moving this 2 into the denominator of a fraction to make the exponent positive. So that's what we're going to do here. For the x, we're going to move the x down into the denominator of a fraction to make the exponent positive. So we get 25y to the 10th over x to the 4th. So when we're done with our exponent rules, we've got to move all of our negative exponents. Okay? All right. Number 3. Now we don't have exponents outside the parentheses, so we don't have to worry about distributing any exponents, but we do have some like bases that we're going to multiply together, like these x's and these y's, right? The 2 and the 5, of course, we can just multiply together and get 10. When we multiply the x's, we're going to add the exponents. Negative 3 plus 8 is 5. The y's, 1 plus negative 3 is negative 2. And so now we want to move. The y needs to move into the denominator to give us a positive exponent. So 10x to the 5th over y squared. And then we're done. Okay? Number 4, more of the same. We want to go ahead and multiply our like bases. The -5 and the 7 are just going to multiply together to give you -35. The x's, we're going to add those exponents. Remember, if we have two separate bases, we want to add and not multiply, so we get x to the 9th. And then the y's, 2 plus, and that's a 1 there, don't forget that. So y to the 3rd. There are no negative exponents, and so we don't have to worry about moving. We don't want to move the -35 into the denominator of a fraction because the exponent is not negative. The base can be negative all day. That's not a problem. It's these exponents that can't be negative. Okay? So we'll leave the -35 alone. All right, number 5 gets us into our division rules. And for me, when you have a fraction, it's a little bit easier to kind of wall off the like bases. So kind of separate them and then just take the columns individually. The 8/12 we can reduce by dividing them both by 4 and get 2/3. And then the x's, we want to subtract the exponents. 3 minus 5 is -2, and I always put those in the numerator to start. And then the y's, 8 minus 3 is 5, so we get y to the 5th. Now that we're done with our exponent rules, we've got to move our negative exponents. And so we get 2y to the 5th over 3x squared. Now we're getting into some types of problems where you might have a little bit different approach. There might be a different way that you like to do this, and that's okay. As long as you get to 2y to the 5th over 3x squared, what you're doing is probably just fine. But we can throw out some of those different ideas and make sure that it'll work for you every time. All right. Next one, again, we're going to wall off and take care of the columns. 100/24 can reduce down to 25/6 if you divide them both by 4. Then the x's, subtract those exponents. 8 minus 2 is 6. We get x to the 6th. The y's, 6 minus, don't forget that's a 1, is 5, so we get y to the 5th. There are no negative exponents, and so we do not have to move anybody. And so 25x to the 6th, y to the 5th over 6. Okay? Whoa, this one's complicated. But take it a step at a time. Do a rule and rewrite. Okay? Now, what I would do first if it were me, and I think, well, not if it were me, but you pretty much have to. You've got to distribute first, right? We're going to do the power rule first. You got to distribute this -2 to all the exponents in the parentheses, including that 2 to the first power there. So do that rule and rewrite. Don't try to go too fast here. You're just going to confuse yourself. And so we get 2 to the -2nd power, x to the +6th, y to the -10th. Okay? Then do the next rule, which for me I think needs to be multiplying the numerator out. Right? So you got 5 times, well, you got 2 to the -2nd power. You can't multiply 5 times 2 to the -2nd power. So I'm going to leave this as 5 times 2 to the -2nd right now. And then worry about combining my like bases. X squared and x to the 6th is x to the 8th. Your y's, 3 plus -10 is -7. All over 25, x to the -8, y squared. You can wall off at this point, right? Now, the 2 to the -2nd power, that needs to move to the denominator. And then, so we get 2 squared times 25 for that first column. Next column, 8 minus a -8. Remember that if you're subtracting a negative, it's the same thing as adding. So 8 plus 8 is x to the 16th. Your y is -7 minus 2 is -9. And so you got to clean it up from here. So we get 5, x to the 16th. I've got to move the y to the denominator because the exponent's negative. In that denominator, I've got 2 squared, which is 4. 4 times 25, which is 100. One more check again tells me that I can simplify the 5 over 100 and just get x to the 16th over 20y to to the 9th, because 5 over 100 will reduce to 1 over 20, and we don't need the 1 in front of the x to the 16th. Again, there may be some different approaches that will get you to x to the 16th over 20y to the 9th. That's just me, right? But do yourself a favor and rewrite as often as it takes to kind of keep things from getting too confusing and too jumbled up. All right? Let's do another one. Okay? No exponent outside the parentheses to distribute, so we can skip that step and go right to multiplying the numerator out. The 3 and the 4 have exponents of 1, so we can go ahead and multiply those guys together and get 12. The x's, there, 2 plus 1 is 3, so x to the 3rd. The y's, 5 plus 3 is 8, so y to the 8th, over to x to the 3rd, y to the 11th. We wall off. 12 over 2 reduces to 6 over 1. I don't need the 1 in the denominator. The x's, 3 minus 3 is 0, right? What's anything to the 0 power? It's 1. So these basically divide out. So the x's divide themselves out. The y's, 8 minus 11 is negative 3. So now we got to drop that negative 3 exponent into the denominator. We get 6 over y to the 3rd. And then we're done. Okay? It can be lots of work. Just do a step and rewrite. And then last but not least here, we've got two fractions that we're going to multiply together. For me, some of you guys may want to go ahead and just multiply the fraction out. Numerator times numerator, denominator times denominator, and that's fine. I like to simplify first, just so that my numbers aren't as big. So I'm going to wall off first, simplify each fraction, and then multiply them together. So 3 over 4 stays 3 over 4. The x's, 4 minus 8 is negative 4, so x to the negative 4th. 2 minus a negative 5 means I've got to make that plus 5, so 2 plus 5 is y to the 7th. And that's going to be times. 6 over 30 reduces to 1 over 5. And then the x's, 3 minus a negative 2 makes that 3 plus 2, so you get 5. So x to the 5th. And then negative 6 minus 8 is negative 14. Now I'm going to multiply the two fractions together, numerator times numerator, denominator times denominator, and then I'll worry about moving negative exponents. 3 times, well, there's nothing to multiply the 3 by, so it stays 3. 5 times 4 is 20. And then the x's, negative 4 plus 5 is 1, so x to the 1st. Then the y's, 7 plus negative 14 is negative 7. We do have to move the y. So you get 3x over 20y to the 7th. Again, some different approaches might work for you here, but this is how I kind of organize these problems. Okay? Hopefully that's enough of a reminder on what you're supposed to do with your exponent rules. Homework sitting out in Canvas, zip through that. We'll take care of any questions and start getting into some Algebra 2 exponents next class.